All right, on number 1, we're looking at finding the measure of each arc. So in this case, what I like to do first of all in a problem of this type is to work with the diagram first and then worry about the arcs secondary. So what you want to do in your diagram is find any missing angle measures first. So in this case, I've got a diameter from point B to point D, and I know it's a diameter because it's a chord that passes through the center. The center, remember, is marked with that point. Now, with a diameter, we know that it cuts each half of the circle into 180-degree parts. So there's 180 degrees over here on this side of that segment. And in this case, these two angles on the right side have to have a total of 180 degrees. So if I take 180 and subtract from that 148 degrees, then the 32 degrees that we get from that, it must be the measure of this angle BAC. But once you have the angle measures in place, then you're ready to determine the measure of the arcs themselves. Now remember, the measure of an arc is the same as or is equal to the measure of the central angle. So in this case, since this angle from B to A to C is 32 degrees, then the measure of that arc is also 32 degrees. Likewise, since this angle is obtuse angle CAD is 148 degrees, then its arc is also 148 degrees. And on the left side of the circle, since we have a semicircle, we have an angle here that's 180 degrees about the center of the circle. So the arc in that case is going to be 180 degrees as well. All right, so then it's just a matter of finding the correct values for these particular desired elements. In this case, we want the measure of arc CD. So from C to D, and we know that's a minor arc from C to D because it only has 2 letters. So from C to D is 148 degrees. Looking at part B, we have a major arc. In this case, we're starting at point C. We're going to pass through point D and go all the way up to point B, which means we're almost completing a full rotation. We're almost going 360 degrees, but we're 32 degrees shy of that. So if I were to take 360 and subtract 32, that would give me the measure of this large major arc. Or the other option that we can take, I know that it's 148 degrees here and another 180 degrees in that position, so that's going to be the arc addition postulate in use. So whether you take 360 and subtract 32 or add 148 and 180, in either form you're going to end up with the correct answer, provided you don't make any mathematical little errors in your addition or subtraction. So in this case, we're going to go ahead and subtract, and we get a measure of 328 degrees for that measure, or that major arc. All right, in part C, we have another major arc. In this case, we're going from B to C to D, and we can see in that case, because BD is a diameter, that must be 180 degrees total. All right, so I would like for you to pause the video, work through number 2 on your own, and then when you've got that completed, come back and check your answers. Okay, so assuming that you've taken the time to do that, the missing angle that we should have here is 118 degrees, which means each of these arcs have a measure equal to their central angle. So this one's going to be a 60-degree arc, this one 82 degrees, 100 here, and 118 there. All right, so the measure of arc BD, adding these two arcs together, we get a measure of 142 degrees. For BED, going in this direction, gives us a total of 218 degrees. And from B to E, simply 118 degrees. All right, number 3, the last thing for this set of notes, determine if, whoops, that should be 2 arcs. I think I have that on your notes. I just forgot to write it on mine when I printed them. All right, determine if arc AB is congruent to arc CD. And remember, we're basing that on the central angle that corresponds to each of them and determining from that perspective. So in this case, in part A, we have arc AB whose central angle is 45 degrees. So this arc measures 45 degrees. Likewise, Arc CD here has a central angle of 45 degrees. So are the arcs congruent? Yes, they are. They both have a measure of 45 degrees. In part B, we have two circles that are congruent. I know they're congruent because their radii are given as congruent lengths. And we can determine the measure of each arc based on its central angle. So here, the measure of arc AB is 135 degrees, like its central angle. Here, the measure of arc CD is 135 degrees, like its central angle. So yes, these are congruent. And the last one, part C. Okay, so we have arc AB here, an arc on the smaller circle, and arc CD on the larger circle. Now, in terms of our definition of congruent arcs, let's kind of keep that in mind. Two arcs of the same circle or of congruent circles are arcs that have the same measure. Now, in this case, in part B, the circles were congruent. We know that because of the radii. So we could determine that the arcs were congruent. What I notice right now in this one, although they share the same central angle here, arc AB would have that measure, arc CD would have that measure, they are not considered congruent because the two circles themselves are not congruent. So in this case, no. And that takes care of our last example in this set of notes.